All right, good afternoon. Of course, he just did an excellent introduction. I appreciate that. My climate research is through the Institute of Advanced Studies in Climate Change. And last year, I started looking into the solar induction effects. I'd written a paper about the earthquakes and the relationships to that, but I hadn't really focused on the sun as much. And so we focused on the Earth first. Get my pointer out, all right. And this Earth is a stellar transformer I put together in about 2015 and presented it at the Electric Universe conference. And the electric universe has some interesting concepts about how most of the things in the universe are driven electrically. So I went ahead and put this stellar transformer video together, and it explains how this switching mechanism at the poles works that changes the lightning distribution on the globe. And I'm going to show you that in a minute, but I've formed a business to kind of take advantage of some of the opportunities, and it's for forecasting not only weather, but we're talking about climate, weather. It's tied to earthquakes, the hurricanes here in Florida, which I'm going to focus on, and volcanic eruptions. So there's a multitude of parameters that are tied to this induction effect. And we're using the Geophysical Intelligence to look at it on Earth, and it's tied to a new framework for understanding space weather. Now the lightning is interesting. You have a global distribution that focused right here. You see the Congo is very dark. This is the highest lightning strikes. These are composite NASA maps over several years, annualized. And you see Venezuela is a lot of lightning too. And then of course Tampa right there has a lot of lightning. There's some other spots, but that's what I'm going to be focused on. Venezuela, Catatumba, is right around there, okay? And what happens is in 2016, the lightning switched from the Congo over to Venezuela. It's like, okay, what caused that? So I used that information. I was looking at some papers and online, and you can actually watch the Weather Channel and see where the lightning strikes are occurring. But I saw that, and the reports also said that the lightning shifted from Tampa, because Tampa has more lightning than anywhere in North America. The lightning shifted from Tampa down to Fort Myers when it shifted from the Congo over here to Venezuela. It also shifted from Tampa south to Fort Myers. Well, when Hurricane Irma was coming in, that was about the time I found that information, and it was 2 days before the European model called the hurricane turn at Fort Myers. I told a friend of mine that works for a publishing New Concepts in Global Tectonics, and I kept emailing him these updates every few days about where the hurricane was doing this and that. So at the end of it, I actually did call it 2 days before the European model based on the information I just told you. And so he asked me to write it up. So I sent that into this conference, and Jib asked me to go ahead and submit a paper about it. So that's what the breakout session is. If you're interested in this, you come to the breakout and you're going to get more details. I was just trying to cover the basics on this. It's tied to this solar induction effect that has an axial and radial component. Now a lot of these coronal holes, these are these big dark spots on the sun. Not to be confused with the smaller sunspots. Those 11-year cycles, those have a different effect. These are huge holes, and this one aligns with the north-south axis. Well, the poles on the sun rotate at different speeds. Not the poles, but the pole rotates at 36 days, while the equator rotates at 27 days. So there's a difference in the rotation rate of the polar axis and the equatorial zone. So the effects affect the Earth that way because it's an induction effect on our planet. In the axial, we have ridges that run north-south, and we have some ridges that run east-west. And I'll show you that in a minute, but it's tied to you have to understand whether the sun's polarity is aligned with the Earth or flipped. And it flips every 11 years with the sunspots. So that's another control that you have to be aware of, because that provides whether it's an attractive force or a repulsive force. If it's attractive, you get a charging effect. If it's repulsive, you get a discharging effect. So that's kind of the basic relationships. And it's real particular to where you're talking about on the planet, because the polarity is tied to Birkeland currents of the sun, the 11-year flip, and then the circuits that you're using on the planet. Let's see if I can show you some of these circuits. Oh, here's one more example of the sun. This image is yesterday. And I wanted to show you this image because we have an axial hole that's in the north pole of the sun. And we have a huge amount of hurricanes being produced right now. And if you noticed, those two that formed recently formed on either side of Florida. And there's an axial induction up the east coast on a triaxic ridge, and there's a Mississippi embayment on the other side. So those two axes were charging up these hurricanes. This image just shows you it's a map. So you can see there's your big hole, and there's some smaller holes along the equatorial region that are just starting to form. They may be getting larger. And then this is your flaring that's coming around, which will be pointed at us in a few days. And this is interactive. This is live. So you can go to this website and check it out yourself. And you can actually compare what's going on in the weather, and you can look at those, and you can start seeing the relationships yourself. Now that alignment is that polar alignment is an axial alignment, and when it gets stronger, these features are streamflow processes on the outer core. A friend of mine I worked with in the Navy, John Quinn, used to do the World Magnetic Model for the Navy. He also worked for USGS doing it. But he created these maps, and it's modeling it's a spherical or harmonic model, but it goes into the Earth and it looks at these relationships, and he picks up these streamflow processes. And this one's in 1900, 1950, 2000. You can see the configuration changes. There was a big event here, and you see how it's east-west here, and all of a sudden you're going north-south. That's your induction effect of the axis induction. There's your east-west radial induction. When this changes in the inner core, it's tied to the solar activity. And this is the mechanism by which the currents redistribute the global electricity or the lightning strikes. So this is the East Pacific rise. You notice this nice alignment right along the ridge where it's going across the ridge east-west here. And then it goes back. This is still kind of a line down here. So it's not a perfect relationship. It's very complex. It's going to take a lot of modeling to really understand it. Now, this is the beginning of our research area. And then if you look at this stream that goes across Africa, this is where that Congo Lightning anomaly was that I showed you, and then it's right next to Lake Victoria, which is the rift. You think the lightning might supply a little electrical energy, joule heating to the volcanoes in that rift? Very likely. And here's a picture of the Congo Lightning, and you got the GRACE gravity data. That's a satellite that collects gravity data. It's really kind of an altimeter, but anyway, you see the signature has a very interesting signature that resembles the lightning. This is where I got the information about the global distribution of lightning changing. This is American Meteorology, Bulletin of American Meteorology, and this is just a news article. This is what I saw first. And I went, oh, Fort Myers, the lightning moved down there. That's where the hurricane's going. It was like, because of the research I'd done before, I'll give you a little taste of that before we're through. And then, there's your rift, African rift in the Congo. So it just rains here all the time. You get a huge lightning anomaly, gravity anomaly. Now I'm going to show you what the gravity shows the circuits on the whole planet in the mantle look like. This is a similar kind of gravity day. They strip the crust off the Earth, and so you're left with basically your mantle, and you see where these orange features are. See, the East Pacific Rise is a north-south circuit connecting the poles. It has these inner fingers right here in Galapagos, and this is where Lake Catatumba is, right here. And there's a connection there with the Cayman Trough to Florida. There's where Irma was coming through. You had the lightning on both sides of it. And then you had earthquakes going off at the same time. And I believe there's a charging relationship of the upper plate, and you get a discharge to equalize that charge. So earthquakes look like they're electrical. They emit radio signals, like lightning strikes. So why would they emit a lightning? I mean, they call it a piezoelectric effect, but the electrical activity precedes the earthquakes in many cases. This southeast Indian ridge, this is your radial component, axial versus radial. And you see it has a connection right to the Congo, right to that rift. So the grounding of the lightning in this area is going to this pole, or this circuit. They're both going to the poles, but this is grounding from this ridge, whereas this lightning grounds on this ridge. It's a pretty simple relationship. I'm going to show you the heat signature that kind of adds credence to my concept. You see the hot circuit of the East Pacific Rise and the Southeast Indian Ridge. You have the return circuits, which aren't quite as warm. A lot of activity on this Western Pacific, though, that doesn't really show on this map. But in any case, this is your global heat flow, and it looks like these are your most active circuits, whereas these are deeper return, I believe. And there's these connections at the poles. Let's see if I've got that next slide. Yeah. These are, again, there's John Quinn's magnetic modeling, and it picks up these spiky looking features, and these are your conduits for energy transfer from the deep layer. The blue is your deep, that's a deeper layer, to the reds are your shallower layer. It's like a capacitor. You have a charge at the different layers. So you get this charge that comes through these features, and it's set up through, this here is tied to this mid-ocean ridge that encircles Antarctica. You have a aurora in space that circles Antarctica. There's a ring-to-ring step-down energy transfer right there. Then you have the inner and outer core, which are two more rings. So you have this step-down energy that charges the Earth or can be discharged from the Earth. And that's your sprites and your elves, and I don't know if y'all are familiar with all that, but there's a lot of phenomena that are tied to it. The North Pole, or this is the South Pole, there's the North Pole. It has the delta configuration. The other was the Y. A quick explanation of the Y-delta relationship is a three-sided pyramid. The top of the pyramid is a Y. It goes down to a triangle, which is your delta circuit. Most basic electrical circuits there are in engineering. Well, these are the delta at the north, and you can see, again, we're using the magnetic model to pick up these spikes, and that's this inner triangle. And then I knew about these areas are pressure oscillation centers. That's the Lake Baikal, Siberian high pressure. It's also a huge continental rift. The Aleutian Islands is a low pressure. These pressure cells are permanent. They just oscillate in the same area. And that's over these vortex structures. I call them tectonic vortex structures. And then Iceland, a known mantle plume. You have the Icelandic low. So these are all pressure oscillations, and they're in this delta configuration. I simply took another triangle and rotated it to see where it would come out. You know, when it rotated at 60 degrees, and it comes out at Kamchatka and the elbow of Hawaii. Well, you know what's happening in Hawaii right now. And you also have the Caspian. That might be a stretch. And then the Hudson. So tectonic features tied to the other delta circuit maybe not as an active circuit, maybe more of a return circuit. The other feature I just wanted to point out is your basic quartz crystal has this same configuration. Quartz has electrical properties, and so you see the double delta configuration in quartz. I'll show you that analogy or relationship. And this ties into the global electric circuit. This fella's got the conventional model up in Boulder. He shows the field of line currents. They're coming into the poles. He shows the auroral ring up here and a ground induction current. Those are the energy transfer step down rings. And you see this feature again. I have this in here. Just Chris Smoot, I used to work with him in the Navy, and he was instrumental in this whole concept because he introduced me to a new tectonic theory, surge tectonics, which talked about vortex structures. And it got me curious because I could see them on our seafloor data with the Navy. It was classified data, and we were seeing stuff that other people weren't necessarily getting that kind of resolution. So we had an advantage of looking at the seafloor that others didn't, and we saw these features. See how we're doing. Okay, these are the auroral rings, and I have an animation, but I want to point out something about these rings. You see how this core, this center part, is on the daytime side, whereas the fat part is towards the night. Same over here on the North Pole. This is the South versus North Pole. When I play the animations, you'll see that this fat part stays to the night side. It's kind of like the magnetosphere in the, around us. You get compressed on the solar side and you get a nice tail that goes off to the night side. Well, the outer core has a similar look. It has this fat part on the outside. And we think this is important because we think that, remember I showed you the streamflow processes? Well, that's what they're on. They're on this outer core. So these streams migrate back and forth with the seasonal tilt of the Earth. Plus there's a lunar tilt. So these controls on this migration of this donut are touching different radial components as you go north-south. And they're also, not touching, but they're related in proximity. And then you get the ridge, the north-south ridges, as this thing rotates to the night side where most of the energy is. As you go past one of these circuits, it's like a motor that's firing off. So you get more than one effect inside. Let me just play this real quick and see if, just to give you a visual. There it goes. And they rotate, instead of rotating the Earth, they rotate the plasma. So you have to think about that a little bit. But you notice the fat part of the donut staying towards the night side. So this is where the energy is firing off. In Lake Catatumbo, the lightning really fires up. Now, it can happen at any time, but it really fires up at dusk. It peaks at midnight, and then it wanes as you approach dawn. So we think this is the control on that. And you could think of this kind of like an MRI of the inner and outer core. You're seeing a reflection in the center of the inner core, and the outer core is reflected in this auroral ring. That's how I kind of conceive it. It may not be a perfect conception, but I believe that's what's going on. And to try to make it simple to understand, you just can compare the sun and the earth to a transformer. And most people kind of understand a transformer. It's not that complicated. These are you've seen the typical one that steps down the energy to your house, and then the substations, which for commercial or subdivisions. But these there's your axial currents. You have a large coil and a smaller coil. You step up the energy, and then it steps back down from the large coil to a smaller coil, and goes into your house through so these are your radial The coils are your radial, and the inline is your axial. So the transformer works the same way. It induces a current in your coil. The big coil does that to the smaller coil, which puts your axial current back in line so you can use it in your house. And then these rotation of the sun, Earth is in this area somewhere. And so you can see this wave is a polarity wave. On one side of that wave is, say, up is positive and down is negative for argument's sake. And as this wave goes through the Earth, you get a polarity change from the wave. And these things can have different kinds of configurations. This is a typical configuration, but it can have lots of different types of configurations. And it can get weak and strong. So there's lots of variables in this. And we're going to experience this every time we go through that wave. Plus, you get the flip of the sun every 11 years. So there's a lot of changes going on, and change is what stimulates the environmental effects on our planet. Okay, I did want to talk about the hurricanes a bit. How am I doing on time here? 5? Okay. I wanted to tell you about what prompted me to look at this. Back in 2004, we had 3 hurricanes that intersected Tampa Bay. Charlie came in from the Gulf. Let's see if I have an image of that. I do not. Oh well, that's my bad. But Charlie came in from the Gulf, and then you had Jeannie and Francis came in from the Bahamas. But they all came in within a few miles of the northern part of Tampa Bay. They all converged in that spot. So it got me curious. And I asked Venezuela for some data. They're the lightning detection network in the U.S. And they shared this histogram with me, 96 to 2004. And you can see in 96 you had about 500,000 strikes. It's not exactly, but it bumps up and down. But in 2003, you had a doubling almost of the lightning in Tampa Bay. Now, Tampa has more lightning than anywhere in North America. So what caused a doubling of the lightning? It was tied to this charging effect. The Earth was discharging here, and it started charging here. So that was I have some curves that show that, but you'll have to come to my other talk to see that. Then you have, this is the concentration of all the lightning strike data over here near Tampa. The hurricanes came out right around here. The intersection of those 3 hurricanes is right about this area, right in the center of this triangle. And if you look at the blue is a positive polarity lightning strikes, which indicates the charge lowering from the ground. It's usually a more powerful lightning strike. But if you plot those, this is all the data. If you plot just this part of it, you get 2 separate poles along the peninsular arch. Hardly any of the positive lightning's hitting over here, where most of the lightning hits. Not much positive here. So again, you're seeing, if you draw a triangle here, you see a delta circuit. And the hurricanes came right through the middle of this delta circuit. Interesting relationships. So that's what got me intrigued to look into a lot of this. Back to the circuits, we discussed the Mantle circuits before. We didn't talk much about an upper circuit where the actual lightning grounds, and that's these crustal anomalies. These are shallower features tied to rifts and other things, but volcanics mostly. They're generally considered basalts. And so you see where those 3 hurricanes intersected. There's Tampa. There's a big magnetic anomaly there. There's your Triassic Rift. There's where the hurricanes are spawning right now, off the Carolina coast and such. Big spawning ground right here, tied to this rift system. And one other thing I really want to show you here is this arch. I used to live in Mississippi when that Hurricane Katrina hit, because that's where the Stennis Space Center is. That's where I worked. And there's this arch feature that stretches from Mobile over to Wiggins, Mississippi. And I'll show you what Katrina was related to. Katrina came in right here. I lived right where that arrow is pointing. Actually, I did. And anyway, you see this colored area here, that's your highest lightning strike activity. That's where the power of Katrina grounded. Just like Irma, when Irma came in, it grounded its lightning right there where the lightning is shifted to. Katrina's going in here. Now, I'm not saying that all hurricanes have this relationship. Some may not. But these did, and they were very powerful hurricanes. Anything else I want to say about that? Yeah, the year before this occurred, I had pine trees in front of my house. I came home from a sea trip one time, and they were all gone. What happened? The next door neighbor told me lightning took them out. They had to cut them down. That was the year before Katrina hit. Also had 2 reports of lightning hitting people's cars and blowing their tire, and they taking out their electronics. You hardly ever hear that. So that happened the year before the storm. Again, just like you had an increase in lightning there in Tampa before those storms hit. And I think I'm going to have to slow down. We got this about wrapping up time. Okay. So I'm doing this, I have an institute for research. I have a business to take advantage of those relationships, and then I can do some consulting work on this area. And what we do is more related to, I don't know if y'all can read that, but we're mostly doing mapping, modeling, and forecasting is our forte, but it's database development. There's the geophysical intelligence is tied to artificial intelligence, but it's real intelligence, not artificial. And so you need big data, and we have data sets that we've developed. We think our data, if we combine them with other people that have vested interest, we're going to see relationships that are very powerful to those, say, insurance companies, those types of people that could really need the forecasting information. And we do field modeling, we do some mapping. John Quinn's still working with us. He's got some really interesting products. And then it's all about these natural hazards. I could tell you about New Madrid. If you come to my talk, I'll tell you about what's going on there. And there's some other things that we could look at. But I'm going to leave it there and open it up for questions for all the speakers. Okay? That concludes my talk.